Hello everybody, we're back again, the saga of the split core transformer. Right, I've redone the schematic with test points shown. Verpes specifically asked to see where we were looking at various the data coming from the circuit. Test point 1 up there will be channel 1 on the fluke. Test point 2 will be channel 2 on the fluke, and then I've got a couple of resistors. I've forgotten to put the values in. They're actually 0.01 of an ohm. Current sensing. Test point 3 is the common, and there's the test point 3 and 4 looking across the resistors, and that will be on the Scopex. Okay, right, that's the schematic out of the way. Now Verpes wanted to know what the DC situation was, so I'll just connect the coils. Those are the two input, and the common on the red to the positive here, and got my little power supply here. I'll switch that on. We have good attraction there, hence I've already checked this. That's why I've put red tape on the cores. Turn it over, current back on. Yeah, definitely repulsion there, so there we are, retraction. Okay, right, we'll switch that off. We'll reconnect our to the two sides of the royer. Common back onto the input on the inductor. Put those out of the way. Right. So I know these are wire wound resistors, Verpes. I'm sorry, that's all I could get at such short notice. But if you, I'll just pop the oscillator on, and this is sort of repulsion mode. We have a volt drop of 1, 2, 3, 2.8 volts, I'd say, across the two resistors. You can see they're out of phase, so they're obviously doing each half. Showing 135 volts being developed. Right, let's switch off. So now then, this was the way it liked to work. Oh, that's a new sound. All sorts of harmonics going on there. Right, still 1, 2, about 3 volts dropped across the resistors. Right, now then, let us insert. I'll pick up coil. Today I've also made a watt box with a 12-volt battery. It's in there. 12-volt battery, 12-volt bulb, little solar cell. Okay, we just lost our supply. And that is actually two and a half. I calibrated this earlier on. 2.5 was 21 watts from a DC supply. Start to bring these together, and goodness knows what's going on there. But even at that, that's 21 watts. What's the volt drop? Volt drop is 2.3 volts across the resistors. Going to that at 70 volts on the and this is with the core virtually separated, as we you can see. Woo, here we go, and it goes ballistic. Volt drop across the resistor, 1, 2, that's increased now, so it's actually pulling more current. Amazing how the waveform changes into this strange. According to that, we've got 300 volts on that 12-volt bulb. 370 volts. Right, let's switch off. Try a intermediate. That was with a 4.5 microfarad capacitor. Go to the 680 nanofarad. As you can see, higher frequency. Oh, right, that's actually showing 21 watts there. Roughly I'd say that was 1.2, 1.3 volts drop across the resistor. Bringing it together. Just a bit of a stability problem here. This old gal is getting tired, the old Scopex. No, can't seem to stabilise it. We've got smoke coming out of the watt box again. Alright, let's just go for the 0.47 microfarad capacitor. That should increase the much higher frequency again. Volt drop about 1 volt now across the CSR resistors, and you see we're still pushing. Why we lost the input volts 24.3. See if I can find what the always do this. That's a frequency of 15.3 kilohertz. Yeah. No, it's not. Put the cores together. The frequency's dropped to 3.64 kilohertz. Nice looking sine wave on there. And this is cooking. That bulb is way above In fact, I don't know whether you can see the smoke rising. It's I think the silicon's but that we're at 2.5 now. That's 21 watts. Right. Well, I hope that's clarified some. The only thing I could do, I suppose, is quickly just see what the input current is via DC means. .34. That's showing 21 watts at that. .69. That's 1.34. Calculator. There we go. 24 times 1.34 equals 32 watts to light up a 21 watt bulb. Very good. We didn't say it was OU, did we? But it's just some interesting thing. And I hope that's managed to clarify a few of the questions that were posed. See what you think. Cheers for now.